T is not in regular text. It is actually green and it is bold. Okay, it's boldface. This means test.out is an executable. Okay, it's using syntax, or not syntax, it's using highlighting to show you special properties of certain files. As an executable in Linux, you can run it. But it doesn't run when you say test.out. Okay, when you press enter, it was a command not found. If you were to do this in Windows or DOS, it would have executed the program because the program is in the current directory. But in Linux, you cannot do it. And that's because the current directory is not on the path. Okay, let me show you what I mean by that. This is what we call the path. In other words, every time you specify just the name of a program to execute, Linux will try to find that particular program in this case, /user/local/bin. If the program called test.out is not found here, it will go to the next one, /user/bin. If it's not found in the first two entries, it will try the third one, and so on. The current directory, which is represented by a single dot, is not on this list. And as a result, when you type test.out enter, Linux could not find the command because it will only look through these particular directory for the file. So that's why if you want to run the program, you have to specify /test.out, because when you specify a directory name, then you're overriding this path here, and you are basically telling Linux, I know exactly where to find this file. It is in the current folder. The slash is a separator, so it's separating the path from the name of the file itself. So when you specify /test.out, it means I want to run the program called test.out in the current folder. Do we have any questions at this point? Okay. And I just ran the program. It didn't do anything, which is good, okay, because at least it did not crash. Could have. Okay, and that's the next step here. Now that is not very fun because you assemble the program, you link the program, you ran the program, it didn't do anything. So to make this more fun, we will use GDB to basically run the program in small steps. Okay, so this way you're not going to fast forward the whole thing. You're just going to execute one instruction at a time. GDB obviously stands for GNU, G stands for GNU, and DB stands for Debugger. Okay, so let's go ahead and run GDB, and then we'll find out what it looks like. GDB /test.out. Now, in this case, the /dot is actually optional. If you do not supply the /dot, it is still okay, because we are not executing the program test.out in this case. We're executing the program called GDB in this case. When you run GDB, this is the prompt that you will get. You get the welcome message, which is from here all the way up to here, and that's it. Then you see the blinky cursor waiting for you to type a command inside the debugger itself. Okay. So getting back to the notes here. The first command you want to learn is help in GDB. Not very surprisingly, right? So let's go ahead and type help inside GDB and find out what it does. So help tells you that you can find help with different categories of commands. One category of commands will be ones that are related to breakpoints. Another category will be related to data. Another category will be related to files, and so on and so forth. Okay? So if you want to find out how do I set up a breakpoint in GDB, you just say help breakpoints. So help breakpoints. And this time it shows you all the commands that have something to do with breakpoints. You can see that this is not done yet because I have to press the enter key to continue or press Q to stop, because once you find the command that you want, then you can say help catch v fork if you want to learn how to use that particular command. So this is actually hierarchical help. You can start with a category, then you move into the actual specific command that you want to look up. In our case, we just want to learn how to set a breakpoint at a particular line or a function. So we want to say help break. Okay, so we'll go ahead and queue to get out of the listing of commands, and then we say help break. And here's the help, or the help text of that particular command. Set breakpoint as specified line or function, and the general use of break is to use the word break itself, supply an optional location, an optional thread, and also an optional if, followed by a condition for a conditional breakpoint. Okay? If you don't specify anything, then the breakpoint will be on the current instruction itself. And it goes further to show you location may be a line number, function name, or asterisk, and an address. If a line number is specified, break at the start of the code for that line, which means you're putting a breakpoint before that line executes. When it hits the breakpoint and stop execution, that line it is before the execution of that line.
So it's at the end of the line before the one specified.
Sorry?
Is the breakpoint's at the end of the line before the one specified?
The breakpoint happens before that line executes. If a function is specified, break at the beginning of that function, but this is assembly language programming. In assembly programming, there is no such thing as a function. There are labels, and then there are labels. Okay? There's no such thing as a variable. It's a label. There's no such thing as a function. It's a label. There's no such thing as a label because it's a label. Everything is a label. There's no such thing as structures because they are all labels too. You'll see. You guys you'll get to that part.
That's scary.
There's no such thing as const because they are labels.
So we only have to learn one thing this semester, right?
Yep, they're all labels. So you have to keep that in mind. Okay, sometimes people will try to map what they already know to what is unknown or what they're learning, which is a good thing. But when you try too hard, then it will actually be counterproductive. Okay, it will actually be counterproductive because when you try to carry certain concepts from C programming to assembly language programming, it will only cause confusion. So a lot of times you kind of have to look from the perspective of the assembler and say, if I were the assembler and I look at this line of code, what would be my understanding of this line of code? Okay, and not saying, okay, this line of code is kind of like that in C. Okay, because when you try to map too hard, it can cause problems down the line. Okay, well, I want to set a breakpoint on a particular line, but I don't know what the program looks like. I can always use another terminal or use another window to go in and edit or view the file. I can do that, but I can also use a command called list inside GDB, and that will basically list the program that I'm debugging. And it is very nice because it will even show the line number for each line of this program. Now, I have not really talked about what this program does, so all I can say is let's go ahead and put a breakpoint on line 7. Okay, for some reason I don't want to put a breakpoint on line 5 or 6. I want to start with line 7. So you can say break 7 to put a breakpoint on line 7. Okay, you press the enter key. It confirms that we are putting a breakpoint at a particular address, and it is, in terms of text, it is in the file called test.s and on line 7. This is just a confirmation that we successfully put a breakpoint on that particular line. So at this point, I can actually start to run the program. Okay, I have put a breakpoint. The program will stop before it executes the statement, or in this case, the instruction on line 7. How do I run the program? Well, you can read my notes, or you can just take a stab and guess what it is. So we can run the program by using the word run. Right here, we can use run to execute a program. You can see that run is in a different font compared to the rest of the text here. So that's a clue that this is actually a command that you have to type in GDB. So I switch back to GDB and I type run, and the program stops at a particular part because it tells me that I'm stopping at breakpoint 1, and this is at test.s line 7, and this is the instruction. Remember, this instruction has not executed yet. I'm stopping before the instruction executes. Any questions at this point? No questions? Okay. At this point, we can look at the value of registers. Once again, we have not talked about the concept of registers. I'm just saying that, well, let's just say that we want to do something called looking at the registers. This is the command that I use to look at the value of registers. So I can copy and paste it here. And it shows me, oh, register EAX has a value of 0, and so on and so forth. Fairly meaningless at this point of time. The leftmost column lists the registers, the middle column lists the value in hexadecimal notation, and the right column lists the value in decimal representation. So you can see that these are the names, these are the values in hexadecimal representation, and these are the same values but in decimal representation, except for E flags, which is actually interpreted into the actual flags. We'll talk about the status flags later on. Yep.
Why does it look like ESP is in hex?
ESP.
Look over to the right.
Yep, ESP is in hex. Both ESP and EBP are both in hex also. Because those two registers are very special. We'll talk about those two registers probably a little bit past the middle of the semester, and it does not make sense to have to interpret those values in decimal. So that's why they're still in hexadecimal, because in general, no one wants to read those values in the decimal form. Okay. When you're ready to exit the debugger, you can always use quit to quit, and if you want a single step, you can use next or step. If you want to just continue execution at full speed, you use continue. Okay, so continue is just running the rest of the program at full speed. If you just want to execute one single instruction at a time, you use step or next. Okay, at this point, they are exactly the same because we haven't talked about subroutines yet. Any questions at this point? Yep.
If you're to run it again, would that break still be there? Or is it
yes. The breakpoint will only go away if you get out of GDB. If you quit from GDB and then go back into GDB, then the breakpoint would not be there anymore.
Is there a way to remove breakpoints without exiting the program?
Yes, you can clear a breakpoint. If I remember, it is clear. So you can clear one, and now there's no breakpoint anymore. Is that it? Or delete? I think it's delete. Sorry. So delete 1 will remove breakpoint 1. In this case, breakpoint 1 is on line 7. So you kind of have to keep a mental picture of where your breakpoints are.
So you can use clear for a line number or delete for breakpoint number?
If you use clear, then you are using a line number, and you're saying clear the breakpoint on that line number, which is helpful. Okay. Any questions at this point about GDB? I'm pretty sure some of you have has a question that you don't want to ask, which is, do real people really use GDB like this to debug programs? And the answer is yes. Yes, go ahead.
I was going to say, so in this case, clear 7 would also be the same thing as delete 1 then, right?
Correct.
Okay.
Yep. Well, we can always try it. Break 7. Oh, by the way, I did not tell you something that's really important. You can use abbreviations. B7 is the same thing as break on line 7. So if I use C7, oh no, C stands for continue. Okay, so because now clear and continue both have exactly the same initial character. So now you have to actually, it will default to 1 when you just type C